As we all know, bulletproof vest can effectively protect the skin tissue from devastating sudden pressure made by the bullet. However, wearing such a vest doesn't mean that you are absolutely safe on the battlefield. Nowadays, all the guns are designed to offer considerable energy so that the bullet will fly at a rather high speed. Therefore, it gains great momentum, which is hard to reduce only by fraction of the air. And then, when the bullet suddenly hit a solid obstacle, like the surface of the bulletproof vest, it will produce strong impact in really short time. This impact will be rapidly conducted to people through the fiber in the vest, which may lead to a sudden shock, even to damage to inner organs. Therefore, finding a material that can reduce and even absorb this strong impact is rather important in order to save more and more life.
To solve this problem, we try to design a kind of bulletproof vest appendage that can be easily attached to the original bulletproof vest, and to be an impact-reducing layer. Under the protecting layer, honestly, the layer is easy to make and design, but the most significant is the material we use to fill up the layer. And now, aiming at improving the capacity of the impact reduction and absorption, our group finds that there exists a new kind of materials that can contribute to our issue. Actually, the inspiration is from a series of videos uploaded in YouTube by a channel called The Backyard Scientist. And this kind of material is called non-Newtonian fluid. So, what is non-Newtonian fluid? Let's take a look at the demonstration first.
This material is called oblique, a kind of non-Newtonian fluid. As you can see, it shows the attributes of liquid generally. This is also oblique, and I can pour oblique from this little container to a bigger one. It also shows the attributes of liquid. Okay, perfect. And we can use a cup of bottle, a cup of water to make a comparison. Here is a pair of chopsticks. When the chopstick slowly penetrates into the two liquid, nothing will happen. It's alright. And even you can stir, nothing different. Okay. Here is a glassy bottle. It's a glass bottle. Absolute solid. We all know if a solid suddenly hit the water, and what will happen? Like this. Let me put it back. 3, 2, 1. As you can see, the water has splashed and a little left here. Okay. It's alright. So actually, have this experiment with water costs a lot, but actually we have to be scientific, right? So I also will do the same things to oblique, but what do you think will happen? Yeah, camera come close. It's really safe. Yeah, okay, thank you. And do the same thing. We just tap this bottle. We just tap this bottle to the surface of this fluid, and okay, let's do this. 3, 2, 1. You see that? Again. Oh. Actually, the fluid have little splashed, but Yeah, always fine. It left a lot. Actually, the fluid can absorb the absorb the sudden heat and impact. This chopstick. No, my God. Can you see that clearly? It actually can absorb the impact.
As you can see, the water deforms more readily than the fluid on the left on this vibrating table.
Object really has some interesting and useful characteristics that we can utilize in lots of different projects. On the one hand, object shows attributes of liquid generally, but when impact is offered to its surface in a very short period of time, its phase changes into solid. These kinds of characteristics make it easy to transfer and attach to modularized military equipment, and simultaneously can effectively absorb considerable energy from the brief heat.
On the other hand, oblique is one that more easy to be artificially sensitized and economically friendly comparing to some other kinds of non-Newtonian fluid like the blood, lymph, and cytoplasm in human's body. Oblique is total made from cornstarch and water. Both ingredients are easy to find even in kitchen and also no pollution at all in synthesis.
And in order to make it easier to demonstrate to all of you, we want to synthesize this kind of interesting material. And so, we have done an experiment. Before the experiment, we gained some information online, which shows that oblique is a mixture of cornstarch and water in a 3:2 mass ratio. However, what we found through the synthesis procedure is that this ratio may be too large, that it will be too hard to mix them up. So, we try to change the ratio to find the best point, such that it is easier to mix up, while keeping its ability to absorb the impact. We have actually attempted for 5 to 6 times, with different mass ratio. This chart is what we summarize our experiment results.
As is shown, with a mass of cornstarch over mass of water equals to 1.2, the product shows the best characteristic that we want. If the ratio is bigger, it becomes real solid, and if smaller, it cannot effectively reduce the impact. However, after some analyzing, we do think, frankly speaking, that this ratio may not be that scientific, even we've tried to measure the mass accurately, because what we used for for synthesis is the cornstarch used for cooking. So there might be some different kind of impurities like sulfur dioxide, which will cause some difference between those results like using the pure cornstarch. But actually, what we got at least does show great attribute of impact reduction and absorption.
And this video is about how we effectively add raw material into the product. This is the fourth time we attempt to add more objects. We changed methods. What we find through this procedure is that it is truly a problem to mix the raw materials up, especially when you add more. If we add water first, the mixture will be easily restructured but hard to control the mass ratio. Meanwhile, if cornstarch first, the mixture will change into real solid, which is very hard to stir and mix. So, the best way obviously is what you can see now. The upper one is pouring water, and the lower one was adding cornstarch. We pour them simultaneously so that they can have physical reaction much faster and easier to mix with the product.
As for alternative materials, wood and rock is considered to be much more efficient materials. However, wood and rock have higher density. Meanwhile, they need to be thick so that they can absorb more energy. So if we just attach these materials, that would be a rather heavy vest. Another considered material is metal. Actually, metal can also reduce the impact without being that thick. However, when bullets hit metal, the strong pressure and friction will make the temperature relatively high in a small piece of area, which may cause fire and burn injury. It might be dangerous. But what about other non-Newtonian materials? What we already know, blood, lymph, and cytoplasm are all non-Newtonian materials, but they are not easy to get from all over the world due to ethics issues. And even we have enough blood, lymph, or cytoplasm, there will also be a truly hard work to purify these raw materials or to artificially synthesize these materials.
To some degree, oblique is really a suitable material for our project. However, during our experiment and process, we discovered some disadvantage using it, so that improvement of the product has to be made, or a new method is needed to attach these materials for reality use respectively.
Firstly, oblique also needs some thickness to show enough ability to reduce the impact. Our original plan for attaching this material is to fill a layer with oblique under the fiber and plastic layers of the bulletproof vest. However, according to the required thickness, the vest will be overweight in the original way. So we just changed the method. We can utilize the thought of modularization design, so we choose to fill some modularized units with oblique and attach these units inside the vest so that it won't need too much oblique, but can show equal effect, and that would be much easier to replace, by the way.
Furthermore, after we synthesize some oblique, we have done a mistake. We just collected the materials in a container and left some air in the container. We have saved the materials for approximately 48 hours, and after that, it degenerated and rolled. It became disgustingly stink, and so no unique characteristic anymore. The truth proved that the duration of objects is not that good, especially when it is contact to air. So we conclude that if we want to apply these materials in modularized units for a long period of time, we must make perfect use of the volume, or we have to make the circumstance real vacuum.
Thinks oblique is a kind of new material that people have not yet made good use of. We believe that oblique has the rather good prospect in future design and engineering. Oblique, or say non-Newtonian fluid, has unique properties which allow it to be used in many different industries. As for military clothing, we believe that oblique can be improved or modified in various ways with different materials so that it can fit in more conditions and satisfy more requirements.